Hey guys, so welcome back. In this video, we'll be trying to solve the problem of the day on Geeks for Geeks of 8th November. Alright, number of parts in a matrix with k coins. So the question is pretty straightforward. You're given a matrix of size n into m. Basically, you have n rows and m columns. And there are a certain number of coins on each cell. Okay, you have to basically count the number of ways to collect exactly k coins while moving from the top left cell to the bottom right cell. So in simple terms, what they mean is the only moves we are allowed to make is down and right. We can't move left or up. Once we start from the top left hand side, the only moves we are allowed to make is to either go down or to either go right. All right. And we have to collect exactly k coins. We have to find out in how many ways can we collect k coins. So in this, 12 is the value of k, right? 12 is the value of k and output is 2. Like there are two ways in which we can collect 12 coins. First way is 1, 2, 6, 2, 1. It adds up to 12. As you can see, the only moves you're making are right and down moves. All right. Or it can be 1, 2, 3, 5, 1. Even that gives you the sum as 12. Right. So there are two different ways in which you can get this particular sum. I'm sorry. Like there are two different ways in which you can get that particular sum. All right. So now let's see how we can solve this. So let's first think about how to solve this. Okay. This is a problem that requires DP along with recursion. Okay, we use a top-down recursive approach along with DP. Okay, so I'll be explaining what DP is used for. All right. So basically, as I said, in DP, normally we only have a single array, right? But in this, let's say memo is what is used to store our sums. Okay, so in this DP will basically be used to store our sum at a particular ij value. All right. So like say for example, I come across 1, 2, 6. Okay. So say for example, my index is um let's say 1 comma 1. All right. So 1 comma 1. So it's 1, 2, 6. All right. My index is 1 comma 1, right? Because it's 6, it's 1 comma 1. Okay. Now what is the sum up till 6? The sum is 9, right? The sum I get is 9 because 1 plus 2 plus 6 is 9. Okay. Now there are multiple instances in which I might take the same path and come to 6. As you can see, there are multiple answers, right? Like one answer what they gave is 1, 2, 6, 2, 1. Another path could be 1, 2, 6, 5, 1, right? And another path could just be 1, 2, 6, 5 or 1, 2, 6, 2. Multiple paths are there that goes along the same route. Okay. So what we'll do is we will store the answer in memo of I, J, current sum. Okay, now current sum will be the current value of the sum what we have. Okay, in simple terms, 1 plus 2 plus 6 in this particular case. Okay, now we will store that because next time we follow the same route, we won't have to recompute the sum again. We can directly go inside our memo table and fetch the sum directly. All right, that's basically how this table works. Okay, now this is where we use DP as well. Now let's think about how to move forward. Right now, this is where the recursive approach comes into play. We can either move right or we can move down. Right. So those two recursive calls will be made. Apart from that, when should we stop? We should stop when the value of I, for example, which is the counter for your rows, when that exceeds n or is equal to n. So n is the number of rows you have, right? And m is the number of columns you have. We don't want our row counter I'm sorry. Okay, we don't want our row counter to exceed the number of rows, right? Because that makes no sense. And similarly, we don't want our column counter to exceed the number of columns. So the base case for recursive functions will basically be I should be less than or equal to n, where n is our row counter, and I is where n is the number of rows we have and our row counter is I. Similarly, our column counter is j, should always be less than or equal to the number of, actually less than, not equal to, it should be less than the number of columns we have. All right, now this will be the base case for our recursion. All right, now here's what we do. We go through the path, we find the sum. If the sum is there inside the DP table, we fetch the sum from there. Okay, and when do we stop? we stop when our current sum is equal to k, right? You have value of k right here. So when our current sum is equal to k, we stop and we can say that we found one right solution, right? So at the end, what should we do? We should just return the amount of right sums we got, right? Yeah, that's the basic approach of how this works. Let's try and code this out, then perhaps you guys will have a much better idea. All right, yeah. Okay, let's start. The first thing we'll do is initialize n to be the number of rows, so that will be len of math, right? Initialize m to be the number of columns, so you can just do len of math 0, right? Because it is going to be a square matrix. All right, yeah. Now after this, you have to create the memo table that I talked about. As I said, you have I, j, and the current sum what you have to store. So it's a triple nested list, I must say. Yeah, it's a bit complex, but it makes sense. So initially, we'll assign -1 for everything whose current sum is not calculated, right? So for k plus 1, it'll be -1. Now, apart from that, for blank in range, for m, right, for the number of columns, then for blank in range, n for the number of rows, right? Now, this is how it works. This is how your memo DP table will look like. Now let's create a main function which is called solve. This will be a recursive function. You'll be having your row pointer, your column pointer, and the current sum, what you use. All right. So instead of this, what is our base case? If I is more than equal to n, right? I should say, just put this here. Okay. Or j is more than equal to m, we can immediately just break out. Right. Immediately just break out saying that it is invalid because we can't exceed the bounds that we have. Now, apart from that, we have to add the current value of our ij value to our sum, right? So current sum will be equal to or plus equal to rather max of ij. All right, so we get the new sum at the point we are at right now. Now, if current sum is more than k, again, we exceeded the value of k, so we don't have to like return anything because from this point onwards, it's like of no use going forward, right? Because the sum already got exceeded. Now, let's go down. Now, this other thing I talked about, if I is equal to n minus 1, like say for example, you reach the end of either the rows or the columns, right? If so, we have to return 1 if your current sum is equal to k, right? Else we can just return 0. Basically, if you reach the end of your matrix and if your current sum is equal to k, only then you return an output 1 or else you return 0. All right. So now, what is there? Yeah, we have to check if the sum we want or the sum of the point that we are at right now, if it is stored in the memo table or not. So if memo ij current sum, right? If that is not equal to -1, basically we have a value stored inside that, we can just return memo ij, right? Ij current sum. Otherwise, what we can do, then we can't do anything. We have to find the sum manually. Now, how do we find the sum? We can do ways down, which will be the recursive function to go down, right? So solve I plus 1 j current sum. Now, this basically ensures that we go to the next particular row. That is when you go down. Now, you can also go right. So ways right will just be the same as this. Solve I, here it will be j plus 1. So to increase the column to go right. Then current sum. All right. Now the recursive part is done. Now let me think about what to do next. Yeah, now we have to store the answer we have into our DP table for the next lookup, right? So now we found a new answer. Since it is not there in the DP table, we have to store it in there. So we can just do memo I of j current sum should be equal to base down plus base right. All right. Now at the end, you can just return memo of ij current sum, and at the end you can return the beginning. So 0, 0, 0, whereas your starting point for rows and columns are 0 and your sum in the beginning is also 0. This should work. Let's check it out. Okay, let's see unexpected indent for loop variables. Oh, My bad. Let's try again. Okay, we got one error. Let's see, expected output is this. We got 000. Yeah, because we didn't call the function. Gosh, okay, fine. Okay, let's submit. Okay, so that's how you solve this problem. If you have any doubts, do let me know in the comment section down below. And that's it for this video. See you in the next one. Goodbye.